Good evening, everyone, and thank you for being here. I want to begin with a simple scenario. Imagine a nursing student. It's midnight. She just finished a long shift and sits down to complete an immersive simulation. The simulation places her inside a real clinical scenario. She has three patients, incomplete charts, and 10 minutes to decide who gets seen first. That's clinical reason under pressure. That's what this course is designed to assess. But instead, she spends 40 minutes trying to navigate the system. She can't find where to click. The camera spins when she does not intend to it. She's not even sure her work's saved, so she just gives up and submits whatever she has. So here's the question that drove the study. Did the assignment assess clinical reasoning, or did it assess the student's ability to survive the platform? This student is not alone. My name is Cindy Kirkman, and my research examines how the complexity of immersive learning environments shapes learning outcomes in asynchronous higher education. And I didn't try to do a full screen because I have issues. I think it's because I'm on a Mac. So let's talk about the problem and why it matters. Higher education has been rapidly adopting immersive learning environments because research indicates they can increase motivation and engagement. But the same data that shows these benefits also show a concerning pattern. More than half of students in immersive environments report difficulty maintaining focus. 42% struggle with navigational challenges that have nothing to do with content they're supposed to be learning. Nearly a quarter experience cognitive overload that directly harm attention. And when students can't find their footing, they stop participating and dropout rates climb by 21%. This study addresses two connected problems. First, these environments can increase engagement, but they also introduce cognitive overload that works against the very objective they're supposed to support. And second, institutions don't have evidence-based strategies for managing that complexity, particularly in asynchronous courses where students are completely on their own. The issue is not whether immersive technology is good or bad. The issue is whether the design supports conditions allow students to use the technologies to demonstrate what they've learned. The purpose of this study was to examine how the complexity of immersive learning environments shape learning outcomes in asynchronous higher education, specifically from the perspective of those best positioned to know, the faculty who implement and manage these environments. To do that, I focused on three things. First, design factors. What features of these environments promote engagement and effective cognitive processing, and which ones hinder learning? Second, faculty perspectives. How educators interpret, navigate, and manage complexity when implementing asynchronous courses. And third, mitigation strategies. What evidence-based strategies can institutions actually use to make these environments work better for students? To get a full picture, I built the study around 5 research questions, and they move in a deliberate direction from awareness to observation to action. The first research question lays the groundwork. It asks how faculty perceive the relationships between complexity and learning objectives. Before we can talk about solutions, we need to know whether faculty even see the problem the same way. The second research question gets specific. Which design features do faculty actually see as helping or hurting students' engagement and cognitive processing? We're talking about VR, AR, simulation, gamified modules, adaptive platforms, and virtual worlds. The full range of tools we're working with, not in theory, in practice, in their own courses. Research question 3 moves from design to impact. What do faculty actually observe students struggling with? Cognitive overload, navigational confusion, usability breakdown, and most importantly, does any of these actually affect learning outcomes? Research question 4 shifts to faculty practice itself. How do they approach implementation to keep their instructional goals intact when the environment is working against them? And finally, the 5th research question asks the practical question. What strategies do faculty recommend for balancing interactivity and loaded to what students experience to what actually works? The study is grounded in 4 theoretical frameworks. I'll walk you through each one and show you how they connect. The primary framework is cognitive load theory developed by John Sweller. The core idea is simple but powerful. Working memory has limits. When an environment demands more than the learners than their working memory can handle, learning breaks down. In immersive environments, just figuring out how to navigate the platform takes mental effort before students has engaged with a single piece of content. That distinction, platform load versus content load, shows up in every single theme. The ARCS model of motivation helps explain engagement, specifically how immersive features sustain or disrupt a student's attention, relevance, confidence, and satisfaction. When those elements break down, students disengage. In asynchronous courses, there's no one there to bring them back. The technology acceptance model explains why some students embrace immersive tools and others abandon them. It comes down to whether the tool feels useful and manageable. When it doesn't, students opt out. And the hunter-gatherer theory adds something the other frameworks miss. Not everyone navigates three-dimensional spaces the same way. Students who struggle spatially aren't struggling with the content. They're struggling with the environment itself, and that distinction matters for how we interpret their performance. These aren't four separate lenses. They work together, and integration is what let me trace complexity all the way from design decisions to what ends up in student submissions. What the literature tells us is encouraging on the surface. Immersive learning environments can boost engagement and motivation. Research puts that figure at about 30%. But the more you dig into the research, the more a pattern emerges. One that tells a more complex story, a more complicated story. 60% of immersive learning studies never even evaluate usability. They're measuring the wow factor, not whether students are actually learning. And 67% of faculty report a lack of adequate institutional supports to implement these tools effectively. They're being handed a powerful tool, complex systems, and largely left to just figure them out on their own. Here's the real gap, the one this study was designed to fill. The literature is almost entirely student focused. There's still limited research examining faculty-centered perspectives on the implementation of immersive learning environments. Almost nothing on strategy specific to asynchronous learning, and no established frameworks for equity equivalent alternatives when a student simply can't access the immersive environment. What we know emphasizes engagement. What's missing explains how complexity actually impacts learning outcomes. That's the gap this study sets to fill. To understand how faculty navigate this complexity, I chose phenomenology as my qualitative approach. Phenomenology is the right choice when lived experience is what you're after. It moves beyond simply what happened to uncover what those events meant to the people who were there. Phenomenology over case study or grounded theory was a deliberate choice because this study sought shared meaning across disciplines and institutions, not a single bounded context or a new formal theory. I recruited 10 faculty members across 10 disciplines. Every participant had used immersive learning tools in fully asynchronous courses within the last 5 years at accredited U.S. institutions. I select participants intentionally, ensuring depth and relevance rather than randomness. For this type of study, 10 participants was appropriate because I was looking for depths of shared experience, not statistical generalization. Recurring patterns appeared across participants and disciplines, which strengthened the transferability of the findings. For data collection, I conducted semi-structured interviews, open-ended conversations that gave participants the room to lead the discussion. Every interview was recorded and transcribed verbatim and analyzed through Braun and Clark's 6-phase thematic analysis approach. I used DEV as my qualitative analyst platform. Thematic analysis lets patterns emerge both inductively from participants' experience and deductively through the theoretical frameworks, keeping the keeping the analyst grounded in both participants' voice and clear alignment with my research questions. From that, 5 interconnected themes emerged. Together, they tell a coherent story about how complexity shaped learning. And I'm more nervous than I was at graduation. Rigor and limitations deserve their own moment before we get to the findings, because in qualitative research, they're not footnotes. They're part of the argument. Credibility came from member checking. Participants reviewed my interpretations to make sure I captured their meaning accurately. Dependability came from a detailed audit trail of every analytical decision I made throughout the process. I was especially careful about confirmability. My instructional design background meant I had real assumptions about these environments. So I kept a reflective journal throughout to make sure that these assumptions stayed visible rather than slipping into my conclusions. For transferability, I provided enough contextual detail that readers can judge what these findings apply and when they don't. On limitations, the study is specific to asynchronous context. I'm not making claims about synchronous or hybrid delivery. Participants self-reported their experience, so recall is a factor, but I mitigated that through member checking and contextual probing during the interview, which helped clarify participants' meaning and reduce the misconception. Data is a reality of a study based on technology that moves fast. These limitations don't undercut the finding, they define where the findings apply. 10 faculty members shaped this study, and the disciplines they represent tell a story on their own. Nursing and emergency medical services, instructional design and cybersecurity, engineering and forensics, marketing and biology, and robotics and film. What struck me the most wasn't the range of disciplines, it was how consistent the patterns were across all of them. A nursing faculty member and a cybersecurity instructor working in completely different fields, where completely different tools were independently solving the same cognitive load problems. Same challenges, same workarounds, arrived at separately. That consistency matters. These patterns didn't emerge from one discipline's quirks, they showed up across all 10. And that raises an important question for institutions. If faculties across fields are solving the same problems in isolation, what would change if they were designing them together? This evidence map shows how the 5 themes connected to my research questions. These aren't isolated findings, they describe a system. Each theme compounds the next, and together they trace how complexity travels through design decisions to what students ultimately submit. The question faculty kept coming back to, can students still demonstrate what they've actually learned? Theme 1 comes down to a distinction faculty made again and again. Not all complexity is the same. One nursing participant had a simple test for her own design decisions. Could an exhausted nurse finishing a shift complete this at midnight and feel like she was practicing reasoning? Faculty drew a clear line between productive complexity and unproductive complexity. Productive complexity supports learning. It means authentic decision trade-offs, discipline-centered challenges, and realistic ambiguity that mirrors professional practice. The cognitive load is created is the kind that actually builds knowledge and skills, what cognitive load theory calls germane load. Unproductive complexity disrupts that learning. It's navigation, uncertainty, interface friction, and unpredictable system behavior. That cognitive load theory calls extraneous load. It can consumes working memory, forcing students to spend cognitive energy on the platform itself. The evidence they needed was getting buried under the navigational confusion and surface level participation scripts that have nothing to do with whether learning actually happened. That's not just frustrating, it means you're not actually assessing what you think you're assessing. Complexity is acceptable when it strengthens reason. It becomes a problem when it hinders, distorts, or replaces that reasoning. How did faculty push back against unproductive complexity? That's exactly what theme 2 is about. One emergency medical service participant described it in a way that stuck with me. Complexity changes the type of stress they feel. Productive stress feels like prioritizing without incomplete information. He called it, and I'm using his words here, stupid stress. When the platform forces them to fight the camera controls and they lose the scene. What faculty developed, often through trial and error, were 3 core strategies: staging, pacing, and attention protection. Staging means introducing complexity incrementally rather than all at once. Instead of dropping students into a full immersive environment on day 1, they build in layers, letting them develop fluency before adding the next level of demand. Pacing means building in deliberate pauses and checkpoints, moments for consolidation before moving forward in an asynchronous course. There's no instructor present to notice when a student is lost and step in, so pacing has to be built into the environment itself. Attention protection means deliberately constructing the environment, reducing visual noise, limiting choices, and focusing the interaction on what actually matters for the learning objective. Faculty were not trying to remove the challenges, they were trying to protect cognitive capacity for the right kind of challenge. That reflects a shift from designing experience to designing cognitive conditions for learning. But even a well-designed environment can break down when students lose their sense of where they are and what they've done. That's what theme 3 addresses. The cybersecurity faculty member said it plainly. Some platforms look realistic, but restrict what students can actually do. If I only grade what the system allows, I'm grading the tool, not the learning. Faculty identified 4 major system level problems. Let me walk you through them quickly. Students couldn't tell what state the system was in or whether they'd completed tasks. Adaptive feedback was often invisible to the student. They got a system response, but they had no idea what triggered it or what it meant. When students hit an error, there was no clear path forward, and automated system cues were sometimes mistaken for instructor feedback, which created real confusion. This matters because asynchronous students often work outside normal support hours. When the system becomes confusing, there's no one to ask. That shifts efforts away from reasoning and toward what the study called task survival. Students stop thinking about the learning objective and start trying to figure out what just happened and what to do next. Faculty responded by adding confirmation cues, building linear task paths with checkpoints, creating off-hours recovery scaffolds, and required written reflections separated from the tool so they could see reasoning the platform couldn't capture. That separation matters. It distinguishes evidence of thinking from evidence of clicking. When a system keeps students in the dark, it doesn't just fail as a tool, it disrupts the evidence of the learning itself. Once the issues of feedback and navigation are addressed, a deeper question surfaced, one about fairness. That's where theme 4 comes in. Theme 4 addresses something that came up in every single interview. Equity isn't just about whether students has access to the tool, it's about whether students can produce valid evidence of their learning, regardless of the evidence they're using, the bandwidth they have, or the conditions of their home environment. Engineering faculty member described one of his students. If a student has a 5-year-old laptop and shared Wi-Fi, the VR walkthrough is not optional enrichment, it's a barrier. I had to build a parallel path that tested the same reasoning without requiring the immersive environment. Faculty described 4 access conditions that created inequity: device limitations, bandwidth disruptions, fragmented home context where sustained engagement wasn't possible, and legitimacy concerns where students questioned whether a virtual experience counted as real learning. But here's what made this more than an equity issue. These factors didn't simply affect convenience. They affected whether students could produce work that actually represented their understanding. That's an assessment integrity problem. Faculty responded by changing the path, not the expectations. Same learning objectives, same standards, but just different routes to demonstrate the same reasoning. Evidence equivalence means preserving the same standards while allowing different ways to meet it when access conditions vary. And that was implications not just for instructional designers, but for IT planning, platform selections, and instructional policies. But even when the faculty solved the equity problem, even when they built alternative paths to maintain equivalent standards, there's a larger question the data kept raising. What happens when the institution itself can't sustain these systems over time? That's where theme 5 comes in. Theme 5 is sustainability, and that's the theme that speaks most directly to IT and instructional technology professionals. Because even when faculty get everything right, when they design carefully, built in checkpoints, and create discovery paths, if the institution itself isn't built to sustain these systems, none of it holds. What faculty describes break down into 4 interconnected problems, and together they explain why so many immersive tools get adopted, launched, and quietly abandoned. The first is recovery infrastructure. One participant described it simply. When they broke, there was no path forward. In asynchronous environments, a broken platform at night can mean a failed assignment or a dropped course. The second is maintenance capacity. Platforms update constantly. Interfaces changes, features disappear. One faculty member said, I spent more time maintaining it than teaching. It's not sustainable. The third is institutional coordination. Faculty, IT, and academic leaderships often operate in silos. And as one participant put it, no one knew who owned the problem. Meanwhile, students were emailing faculty because the assignments were due. And the fourth is transparency. Immersive platforms increasingly make decisions about what students see and do through adaptive logic. But faculty can't explain how it works, and students don't know how it happens. That's accountability gap belongs in the IT governance conversation. Together, these problems show why immersive learning cannot be treated as a tool adoption issue alone. It has to be treated as a systems sustainability issue.
Hi, Cindy, you have 5 more minutes for the presentation.
Okay. 5 themes, 5 research questions. Here's what they add up to. Across every interview, faculty kept coming back to the same questions. Can students still show what they actually learn? Complexity isn't just effective engagement, it shapes what students can show you and end in. Let's just move faster here. My unique contribution to the body of knowledge. So what does this study actually add to this conversation? Doctoral work is judged by its contribution. Here's what this study adds. The primary contribution reframes how we think about cognitive load. Cognitive load theory has traditionally treated cognitive load as a design input, something you design around to prevent overload. This study repositioned it as a diagnostic output, something you can read into students' work to evaluate whether decisions actually work. That's a meaningful extension of the theory. The second contribution is cognitive load pathway framework, and y'all can't see that because it's in my paper. Third, evidence equivalence as an assessment integrity concept. It reframes equity not as access to the tool, but as access to a valid, fair opportunity to discriminate learning regardless of what path the student took. Fourth, a set of faculty identified mitigation practices, staging, constraining choices, embedding recovery scaffolds, and building confirmation cues that work across platforms, not within specific tools. These aren't theoretical, they're what faculty figured out under real conditions. Let's just go to, skip down. So I want to end where I started. That nursing student at midnight, she was not failing because she lacked clinical reasoning. She was failing because the system made her reasoning invisible. That's the problem this research was built to address, and the answer isn't to slow down adoption. It's to ask better questions before the decisions get made. Now, how impressive is it? But does it preserve the conditions for learning? Does it keep cognitive load manageable? Does it produce interpretive evidence? Does it work when a student's laptop is 5 years old and their Wi-Fi is shared? Those questions, grounded in faculty experience, shaped my cognitive load theory and tested across 10 disciplines, were the contribution I'm most proud of. To my committee, I thank you. I wouldn't be here without you and your guidance. And that's what and with that, I'm ready for your questions.
Thank you, Cindy, for your presentation. Does anyone have any questions for Cindy?
Of course, I have questions.
Of course you do.
Of course I do. Of course I do. And I'm driving on I-5, so sometimes this fades in and out. And I was listening. I was not watching. Which 10 disciplines, and you may have mentioned this, did you focus on?
It was 10, but actually all of them were different. I wanted all 10 different disciplines that I.
Oh, there you go.
Biology, film, actually computer science.
Okay.
10.
And cybersecurity.
Yeah.
So my question would be, could this be applicable to a City U environment? Would there be an advantage to it?
There's always, in my opinion, I've done a lot with immersive learning environments. I did with the community college here with the emergency medical students. We did a pilot with 3D headsets. One of the things I was really interested in was actually how these immersive platforms could be implemented into learning management systems. And that was kind of where I was looking for with my original topic. But Paul and I ran into some issues with being able to test that and implementing that. I didn't really have a test platform. But I think that, yes, like I said, especially with virtual worlds, I think is huge. As many of you know, that when I did my master's degree, I am a very visual, hands-on learner. I don't learn well from just reading a textbook. And reason why I have 2 master's degrees is I had started a master's program at Western Carolina and East Carolina, and was almost finished. And I'm sitting here thinking, I really haven't learned anything. And I'm like, I can go ahead and finish this, but I just feel like I didn't know anything. So I actually found another program was kind of along the same lines at Appalachian State. And what I liked about them is they had, I don't know if any of you are familiar with the game Second Life or Sims.
Oh my God, yes.
Okay,
Yes.
so I did some teaching when I was teaching at community college. I did teaching in Second Life, building with 3D modeling in Maya. But one of the things that I really liked about them is there's a lot of universities that are actually in Second Life, but I think there's some negative connotations to Second Life. Appalachian State used a program called OpenQuack, and it was kind of along the same lines, but it's strictly for education. And so we had a virtual campus, and we had virtual lecture halls, and we had cohorts, our cohort, and in our cohort, we had two classes, a semester. And on Tuesday night, we met for one class, and on Thursday night, we met for the other one. And we had our professor was there, his little avatar, and we sat down in our little lecture stadiums, and he had his presentations and stuff. And then we would break out because we had a lot of team projects, and we would break out into our team breakout rooms and talk about our projects. And it did a lot of things. Some of the social aspects is when you're doing online learning, you feel that disconnect from your fellow students. And it's like I said, I think with this cohort, we did pretty well. Like Scott and Jamal and Corinne, we kind of, we created this Teams group, and we chatted amongst ourselves, but that kind of social aspect is missing, but that included that. And I had a research class that I was really struggling with, and I probably might not would have made it because it was really, really hard. And I'm thinking, oh my God, what did I miss in my bachelor's degree that didn't prepare me for this, But we were all talking about this instructor was just so hard. And we all was like, oh my gosh, I know it's so hard. And they were all so hard. So we encouraged one another and we helped each other. So it also builds that. I'm a very avid person for immersive learning tools in education, because you go through, you post to a discussion board, you read a chapter, you take a quiz, you write a paper. Are you really learning anything from that? You're not having that hands-on knowledge, and that you don't feel like it's doing you any good because you're not putting that to work. You're not seeing anything from it. Kind of like the classes that we had that had labs and stuff with it. Those were really great because you were doing hands-on, you were seeing something.
So I go back to my question, having gone through this from your instructional design perspective, if someone gave you a magic wand based on what you're learning, given the limitations of our platform, what changes, and I don't expect a complete answer now, but what changes could we implement that would measure, that would accurately demonstrate what students had learned, as opposed to passing a test, giving a grade, something that's truly functional, where that they understand it. Like that's why you did your second master's, right?
Yeah. I think, like I said, my biggest implementation, my first step would also be, to be the virtual world. As like I said, that brings a lot of, you have your instructor there that you can ask questions, you're seeing the visual, you have that connection with your classmates and your cohort group. That would always be my first starting
Your
point.
first go-to.
Yeah.
Did everyone have an avatar?
Yeah. Oh, yeah.
You have to in Second Life, right?
Yeah, you had to. Actually, I think it was,
Okay.
like I said, with Second Life, there's so much other stuff. With OpenQuack, I believe it was designed specifically for educational.
Okay, that would be really cool to be able to implement.